Okay, let's unpack this. We have a pretty high-stakes strategic assessment in front of us. And it looks like Northern Eurasia is facing a high moderate risk for severe winter weather. We're talking December 10th to the 19th, 2025. This is not your standard forecast.
No, not at all. The alert is flagging major infrastructural disruption, and the confidence level is so high because it's not about just one storm. It's driven by a rare synchronization of, these huge global climate drivers, a real perfect storm setup.
So our mission today is to figure out what those drivers are and why they're making this specific window so dangerous.
Right, and the sources point to two main triggers.
Okay, so first up is a weak La Nina event. It's been persisting and it peaks right in early December. That's piece number one.
Yes, but the real game changer here, the second piece, is a major disruption of the stratospheric polar vortex, the PV, and it's happening unusually early this year.
That PV disruption is the trigger then, but the engine is the atmospheric block that comes after.
Exactly. When the PV gets destabilized like that, it forces the whole system into a strongly negative phase. For both the Arctic Oscillation, the AO, and the North Atlantic Oscillation, the NAO.
So the negative NAO, that's not just jargon, right? That's the mechanism that actually controls the weather patterns on the ground.
Precisely. Think of it like a giant wall of high pressure that just gets stuck over the North Atlantic. Normally, that deep Arctic cold just spins around near the pole. But this wall shoves it. It shoves all that Siberian cold directly west.
And it aims it straight at Europe. So what does that mean on the ground? The assessment calls it the Great Continental Divide.
And this is where it gets really interesting. The continent basically splits into two distinct weather regimes. Western Europe, for the most part, gets what we'd call a mild maritime storm regime.
So milder conditions, but still dangerous, like windstorms and flooding?
Yes, lots of rain, sequential storms, which leads to fluvial flooding, rivers bursting their banks. But the moment you move east, you cross that line.
And you're into the severe continental winter regime. That's the deep, cold air.
And where they meet is the collision zone. That's the maximum risk area. It stretches from Central Europe, down through the Balkans, the Black Sea, and all the way to the Caucasus.
And that's where the two air masses clash.
They clash violently. You get extreme cold hitting all this abundant maritime moisture. And that is the perfect recipe for severe, rapidly intensifying storms.
So let's talk about the hazards in that collision zone. We're talking, what, severe blizzards, flash freezes?
All of that. And critical icing events. We have historical analogs for this kind of setup. They've produced massive early winter snows before. I mean, we have documented cases of 50 centimeters of snow in major cities.
50 centimeters, that's nearly 2 feet. That shuts everything down. Transportation, power, everything.
It brings entire systems to a halt.
Okay, but here's the thing that might confuse people. How does a massive cold outbreak like this fit into a warming climate? Shouldn't it be getting, warmer?
That's the paradox. And it's where climate change actually acts as an amplifier. The cold outbreak itself is a natural event driven by the PV and the NAO. But the background atmosphere is warmer now, and warmer air holds more moisture. That's the Clausius-Clapeyron relationship.
So when this natural cold event happens, the storms have more fuel to work with.
Far more fuel. The precipitation is just so much more intense, heavier snow, more damaging icing events than we would have seen, say, 30 years ago.
And that icing threat is a particular worry for northern and northeastern Europe, right?
Absolutely. Those regions already show an upward trend in what we call icing potential days. So you get all this moisture meeting that sub-freezing air at the surface, and you're pretty much guaranteed to see debilitating icing on power lines. Widespread grid failure.
We also have to flag the unique risks in the Caucasus. It's not just snow and ice there.
No, it's a multi-hazard situation. Long-term glacier retreat has made those mountain environments very unstable. So when an intense precipitation event like this hits, it can trigger cascading geo-hazards, avalanches, flash floods, debris flows. It's extremely dangerous.
So what's the bottom line here for you? The key takeaway seems to be that this is all about synergy.
It is. You have these synchronized global drivers creating the opportunity for extreme cold.
Yeah.
And then you have the background climate trends amplifying the intensity of every single hazard that follows: the snow, the ice, the flooding.
Right. And while the main drivers, the La Nina and the PV event, might weaken by January, the story doesn't end on December 19th.
Not at all. And this is the final thought for you to consider: the deep, widespread snow cover that gets laid down during this event. It acts like a giant refrigerator for the continent. It can exert its own localized cooling effect, sustaining colder than normal conditions much deeper into January 2026. So operational readiness has to be maintained long after this initial storm window closes. The effects will linger.